on Lab 5. The purpose of this laboratory experiment is to compare experimental plots of motion with computational models of two cards undergoing an elastic collision, and to observe what happens to the total momentum and energy of the system as the cards collide. To use this, I used CloseScript and Tracker to analyze the video, and some fundamental physics concepts needed and applied throughout the experiment, just general knowledge about collisions, the conservation of energy, and the conservation of momentum. So predictions. I predict that the computational model will not quite match the experimental model because of assumptions and errors that will be made in making the computational model, and also that the total energy momentum are constant. The system is defined as the two cards which are undergoing the collision, and the surrounding includes the track, the hand, and everything in the surroundings. And this is the video I took from YouTube for the experiment. So this is what it looks like on Tracker. Tracker gives me the data of the time interval, the position, and the velocity of the two cards. And this is what I use for the initial conditions that I then used in my computational model. And then this is my code for my computational model. I first set my initial conditions for the position and velocity, taking the information from Tracker. Then the delta t was also taken from Tracker. Then I set the initial energies and the initial momentums, and inside a while loop, I iteratively updated the velocity and position of the cards to then calculate their new momentum and energy. And this is just to plot the graphs at the end that we'll see briefly. So some assumptions I made when I was using this computational model, I assumed that the velocity was constant and that the net force acting on the cards was 0 newtons, and we will see later why this causes some errors in the experiment. And as you can see, I first did a while loop for up until 0.635 seconds, and then another while loop for up to 1.81 seconds, because the first while loop was to get all the information before the collision, and the second while loop gets all the information after the collision. And inside the while loop is the same thing. And this is what the model looks like on GlowScript. Yeah, as you can see, I plotted in red the first card and in blue the second card. So as predicted, the competition model, although it very closely resembles the experimental model, they don't quite match because of some inconsistencies in real life that the competition model does not account for. For example, we do not take into account friction and other resistance forces that we will see later on, and also the application of Tracker is not perfect, so the data itself is not perfect. And as for the energy momentum, they are constant throughout the interaction, and this is because in perfectly elastic conditions, both the momentum and energy of the system are conserved. So some errors and assumptions, as I briefly mentioned already, friction. We do not take into account friction between the wheels of the carts and the track. We also do not take into account air resistance and other forces that may occur from the surroundings. And these actually result in a different velocity from what the true velocity should be, and a different position from what the actual position of the cart is. And yeah, since we don't take into account these forces, the velocity is not actually constant, even though we do assume it to be constant. So what if we knew the coefficient of friction and air resistance? Well, with this information, we could get a more accurate representation of the actual motion that the carts are undergoing. However, this will result in a change in momentum and a change in energy because both friction and air resistance are doing work on the system. And what if the mass of the carts were not equal to each other? So what if, for example, the first cart had double the mass of the second cart? In this case, if we do not take into account the friction and air resistance, just taking into account the change in the mass, then the momentum will still stay the same, but it will be greater than it was before. Because, well, the mass, which is directly proportional to the momentum, and so an increase in the mass will lead to an increase in the momentum. And the energy will also be increased because the only energy we are really considering, the only energy that we should consider is the kinetic energy, which is also directly proportional to the mass of the object. So an increase in the mass will lead to an increase in the energy of the system. This has been my presentation. Thank you for your time.